Okay, so the idea now is to look on a very nice relationship or the connection. We will learn on the connection or the relationship between the minimal polynomial and the characteristic polynomial of a matrix. So, through the exercise, we will learn about that. So we have a matrix and some real matrix, and the characteristic polynomial is defined by this polynomial t plus 1 and t squared plus 2t plus 1. And I have a minimal polynomial, which is this one, t plus 1. Now, the question is, can such a matrix exist? Can such a matrix with a characteristic polynomial of this one and a minimal polynomial of this one, can such matrix exist? And now we need to know the relationship. What should be the relationship between the minimal polynomial and characteristic polynomial in order to understand if this can even happen? So, uh, the basic relationship is that the minimal polynomial must have the same roots as the characteristic polynomial. Every root of the characteristic polynomial should be also a root of the minimal polynomial, so it must be. You cannot have, for example, a root of 2 for the characteristic, but the minimal won't have it. All the roots of the characteristic should be also in the minimal. Now, also the minimal should divide the characteristic polynomial. Those two conditions that I just mentioned must exist in order for a minimum polynomial to be a minimum polynomial of a matrix. Now, it's not sufficient because you also need the minimal polynomial which annihilates the matrix. But when you apply it, but you need that the roots will be the same and the minimum polynomial will divide the characteristic polynomial. Okay, so let's look on the characteristic polynomial, what we can learn from this. Note that this part, which is t squared plus 1 plus 2t plus 1, is just t plus 1 squared. Yeah, you can open this and see. Uh, as such, you can write the characteristic polynomial just as t plus 1 times t plus 1 squared, which is t plus 1 uh, to the third. Now, what are the roots of this characteristic polynomial? Of course, it's 0 and minus 1. So you can see, and when you look on the middle polynomial, you see that the roots of this polynomial, again, is 0 and minus 1. The power of t plus 1 is different, but it doesn't matter. What it matters is that they will have the same roots. So yes, we have the same roots. Now about dividing. When I try to divide the characteristic polynomial by the minimal polynomial, when I do that, the result is a polynomial. Therefore, it means that the minimal polynomial does divide the characteristic polynomial. That's good. Okay. So, can it be a minimum polynomial? It also should annihilate the matrix, both of them, by the Kelly-Hamilton. Therefore, it will because it has the same roots. So, yes, this can be a characteristic polynomial and a minimal polynomial of a matrix. Now, does a matrix as such exist? Now, the key theorem in linear algebra says that if a polynomial minimal polynomial divides a polynomial characteristic polynomial and they share the same root, then there exists a matrix whose minimal polynomial is this and characteristic polynomial is this. So there is such a matrix. Now we also can find the matrix which all these things came from. We know that the roots, which are the eigenvalues, are 0 and minus 1. So 0 and minus 1 should be the eigenvalue. Now, if the minimal polynomial has distinct roots, you can also know that the matrix is diagonalizable. So there is a diagonalized form for this matrix. And the roots are only 0 and 1 and minus 1. Those are the eigenvalues of the matrix. And you also know that there are the max size in Jordan form of minus 1 is 3 and of 0 is 1 because this is their power in the characteristic polynomial. So this is the matrix we get 0 one time and minus 1 every one of them uh, until we get to 3 of them because the power of the characteristic polynomial is 3. This is the matrix that has the characteristic polynomial we talked about and the minimal polynomial that we talked about. You can just calculate immediately the characteristic polynomial, which is exactly what the characteristic polynomial is. So we talked a little bit about the relationship between the characteristic polynomial and the minimal polynomial throughout this example. Of course, it was just an example. We talked about the roots that should be the same, divisibility, the minimum polynomial should divide the characteristic polynomial, both will annihilate the matrix, and there will be a matrix that satisfies this. And in this case, because the minimum polynomial can be is a distinct has distinct roots, so the matrix must be diagonalizable. So we have a diagonal matrix, and we even constructed the matrix throughout the characteristic and the minimum polynomial. Thank you very much. I wish that you learn a little bit about the minimum polynomial and the characteristic polynomial. If there are any mistakes or corrections, please tell me. Thank you all very much, and thank you for watching, and that's it for now.